So if you focus on the ink dot in the center, you'll notice that pretty quickly it starts separating into orange and blue. And this was originally a brown Dixon pen. So the orange goes up top and the blue stays on bottom as they keep moving up. And after a while of them moving up on the chromatogram, you'll notice that a yellow starts to form in the middle. You can kind of see it in there. And you can see that a tiny bit of like magenta-y pink coming out at the bottom. And so they keep moving up and keep moving up. The orange like stretches out and starts getting bigger, as well with the blue and the yellow that's in between them. So once you get to this point, you can clearly see the different pigments. There's pinkish magenta on the bottom, blue, and then yellow and orange. And between the yellow and blue, there is a sort of green showing up, but I believe that that's not its own pigment. It's instead just the yellow and blue getting kind of blended together. In the end, when you look at it, you can see a clear orange pigment at the top, followed by a yellow right below that, and then blue, with a bit of green between the yellow and blue, kind of as a result of the blending. And then below the blue, a pink, and a little bit of purple between the pink and blue, also because of blending. So now let's take a look at why the pigments moved as high as they did, and what the significance is of their height on the plate. The higher a pigment moved on the plate, the less polar it is. So for example, the orange/pink pigment that's at the top of all three inks is the least polar pigment in the pens, and the same thing goes basically for if a pigment is further down on the plate. That means that it is more polar and has a lower RF. RF value is another way of describing the retention factors of different inks, and is found by dividing the distance the ink moved by the distance that the solvent moved in total. In this photo, you can see that these orange/pink inks at the top have the highest RF value, meaning they are the least polar, and likely made out of the same pigments. Similarly, in this photo, you can tell that the magenta and blue inks in the middle pen have the lowest RF value, making them the most polar out of the pigments. RF values are useful to compare different inks in a chromatogram. If two different dots have the same RF value, then they are most likely the same pigment. This can be useful for things such as crime scene investigation and additive detection in foods.